viewers, we are considering set theory, and under set theory we'll be given this example. And so we'll be given that the universal set, and this means that X is a member of a subset such that its boundary, it is between -4 and 8. And so what this is greater than, or equal to, while this is less than or equal to. So in this first instance, we are told that the universal set X is a member of a subset such that its boundaries between -4 is greater than or equal to -4, and then less than or equal to 8. The same thing applies here. We are told that X is greater than 0 or less than or equal to 5, and here we have that X is greater than or equal to -3 and less than 3. So we are going to be interpreting this, and then when we are done bringing out these values, we can now find our A intersection B, A intersection B prime, B intersection A prime, A union B, and A union B, all brackets prime. And so let's bring out the values of universal set. Note, I have said in one of my videos on set theory that there are different ways of representing sets. We have the roster method and we have the set builder method. So this is an example of representation of a set using the set. This is the set builder method of representing set. So let's take solution. So let's get the members of a universal set from this. So a universal set will be equal to, since we are told that X is greater than or equal to -4, this means greater than or equal to. So this is greater than or equals to -4. So we are going to take, since it is equal to, we are going to take from -4. So we have -4. The next will be -3, -2, -1, 0. And then this one is less than or equal to 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. We stop here because they said it's less than or equal to 8. We stop at 8. And so for our set A, we are told that X is greater than 0 and X is less than or equal to 5. So if X is greater than 0, it means X is from 1. So we have 1. And then X is less than or equal to 5. So this will be 2, 3, 4, 5. So we are done with our A. And then for B, we are told that X is greater than or equal to -3 and X is less than 3. And so if X is less than 3 at this point, it means we are going to stop at 2 here. Okay, but X is greater than or equal to -3, so we start from -3. We have minus, so we start from -3 since it is greater than or equal to -3, comma, -2, comma, -1, 0, and this one is less than 3, so we have 1, comma, 2. So that will be all for our interpretation of the set builder method of representing set. And so since we've gotten a union of a set, these members or the element of set A and that of B, we can go ahead to find the solution to this question. So the first one is we have our I is A intersection B. So what this implies is the element you have in A that also appears in set B, element of set A that also appears in set B. So if you look at set A, we have 1, and again we have 1 in set B, so 1 is part of it. We have 2 in set A, and there is 2 in set B. So we have 3 in set A, there is no 3. What we have is minus 3. 4, there is no 4. 5, there is no 5. So A intersection B is 1, 2. And so we find the second one, II, which is A intersection B prime. So what this means is elements of set A that are not in B. A intersection B prime means elements of set A that are not in set B. So what are the elements we have in A that are not in B? So let's check. We have 3 in A and we don't have 3 in B. So okay, let's start with this. We have 1 in A and we have 1 in B. So it's not, we have 2 in A, we have 2 in B. No, we have 3 in A and we don't have 3 in B. So 3 is one of the elements that is in A that is not in B. Then we have 4. 4 is in A but not in B, so we take 4. And then we also have 5 to be in A and not in B, so we take 5. So A intersection B prime means elements that are in set A but are not in set B. And so the next one is B intersection. We are looking at this. Okay, I. So B intersection A prime. So this one means elements that are in set B but not in set A. So if you look at it, minus 3 is in set B and not in A. Minus 2 is in set B and not in A. Minus 1, yeah. Minus 1 is in A, B and not in A. Which other one? Okay, minus 1, we have 0 is in B and not in A. Is that all? 1, 2, 3, 4. Okay, so that's all. So we have minus 3, minus 2, minus 1, 0. So those are the elements that are in set B but not in set A. So that is what B intersection A prime means. So we go to IV, this other one. So IV, that is to find A union B. So what this implies is we are going to bring together all the elements that are in set A and all the elements that are in set B. That is the meaning of A union B. All the elements in A, all of this, and all of this. So, but you're not going to repeat any elements. So let's take the elements in set A first. 1, 2, 3, 4, 5. So we take 1, 2, 3, 4, 5. Now we are done. So for set B, we take minus 3, minus 2, minus 1, 0. So we are not going to take 1, 2 because already we've taken 1, 2 that is in A. So this is the result for A union B. All the elements in A, and we bring it together with all the elements in B. And so the next one is for us to find V is for us to determine in brackets A union B in bracket prime. So what this means is, all the elements that we have in the universal set that is not in A and also not in B. I repeat, this means A union B into bracket prime means all the elements we have in the universal set that we can't find in A, and we also cannot find those elements in B. So let's look at those elements that we have in universal set that we don't have in A and B. So if you look at it, we have -4, there's no -4 here, there's no -4 here, so that is 1. So we have -4, comma. What else? -3, okay, we have it in B, so we are not going to consider it. -2, we have it in B, we are not going to consider it. -1, we have it in B, we are not going to consider it. 1, 2, 3, 4, 5, we have it in A, we are not going to consider it. 6, there is no 6 in A, there is no 6 in B, so we take 6. And then if you check 7, there is no 7 in A, there is no 7 in B, so you take 7. And then there is no 8. If you look at the universal set, we have 8. There is no 8 in A, there is no 8 in B, so we take 8. So that will be all. So that is A union B into bracket prime. What it means is elements that are in the universal set, but you cannot find it in A and B. So viewers, basically, that is how to approach a problem of this nature. Thank you.